नमस्कार बच्चों, मेरा नाम है धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री का फर्स्ट लेसन सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री। इसमें लास्ट वीडियो में आपने सर्टेन कॉन्सेंट्रेशन टर्म्स देखे होंगे, लाइक मास टू मास परसेंटेज, वॉल्यूम टू वॉल्यूम परसेंटेज, मोल फ्रैक्शन, ppm, parts per million, etc. Right? And now what we are left with is the two concentration terms, molality and normality. Okay. So after, as I told you, after finishing these concentration terms, we will be doing the past paper questions from JEE and NEET questions. Okay. So today we have to complete molality and normality. ओके, मोलारिटी हमने किया था लास्ट वीडियो में, मोलारिटी तक कर लिया था। अब हमें मोलालिटी या नॉर्मलिटी देखना है। सो शेयरिंग द स्क्रीन। मोलालिटी, ओके, सो वी स्टार्ट विथ मोलालिटी। हमने मोलारिटी किया था, आपको याद ही होगा मोलारिटी, राइट? So molarity, just revising molarity, it is denoted by capital M. So I've just showed it in the screen just to molarity, M, capital M, okay, and it tells you about the number of moles in 1 liter of the solution. We are talking about solution. All the concentration terms, whatever we did till now, was dealing with volume of the solution, okay, or the mass of the solution, okay. In case of mass by mass percentage, it was mass of the solution, okay. So molarity is capital M. It is the number of moles in of solute in 1 liter of the solution, okay. So today we will be learning about molality, L, molality. Okay, it is denoted by small m, and it tells you about the number of moles of the solute in 1 kg of solvent. Okay, so that's why I was just stressing on that all this time we were talking about solution, but in molality we talk about the solvent. So what is molality? Molality is the number of moles of the solute in 1 kg of solvent. Okay, so students, molality, it is represented by small m, and molality is number of moles of solute by mass of solvent in kg. Okay, so this is the formula. This is what you have to memorize and keep in mind. Okay, so all this while we were talking about solution, but in molality we talk about the mass of the solvent, okay, in kg. Okay, so let's do a question. So question is over here. First one, find the molality of 20 grams of NaOH dissolved in 100 grams of the solution. So I'll just write down the information. 20 grams of NaOH in 100 grams of solution. Okay, sorry, 100 grams of the solvent. Okay, now so this is 20 grams of NaOH in 100 grams of the solvent. You need to find the molality. So this is just the basic question, that's applying the formula, that's it. So molality, sodium is 23, oxygen is 16, hydrogen is 1. Okay, so molality, number of moles, you already know the formula, mass over molar mass. Mass is 20 grams over molar mass, 23 plus 16 plus 1 over 100 So this is equal to 40, right? So I'm just writing it directly. You already know how to find the molar mass now. Over mass of the solvent in kg. So 100 gram is the mass of the solvent, but I need it in liters. So I have to divide by 1000. So 1 liter is equal to 1000 milliliters. So I have to make it into liters according to the formula. So this comes to how much? If you solve it, it comes to 5 small m. Okay, so this just, you cancel the zeros. So it is 5m. This is the first question. Okay. So I'll just share the question so that you, okay, so this is the question. Okay. Now the second question is, you need to find the molality if 0.85, I'll just write down the information, 0.85 grams of ammonia is dissolved in 100 ml of solution. This is solution. This is not solvent. This is solution. Okay, find the molality, and the density is given as 1.2 grams per ml. Okay, so I've written down the information. Just share the screen. Okay. So this is the, yeah, I have written down the information. 0.85 grams of ammonia is given to you and 100 ml of the solution. But you need solvent, right? So here, can we find the mass of solution from here? Mass is equal to volume times density, right? Volume is 100 ml times 1.2 grams per ml. So does it give you 120 grams of the solution? You know the mass of the solution, you know the mass of the solute. So how can you find the mass of solute? Sorry, mass of solvent. 120 minus how much? 0.85, right? So 120 minus 0.85, you can get the mass of the solvent, right? Which is equal to 119.15. So now you have the mass of the solvent. This is grams, right? You have the mass of the solvent with you. You have the mass of solute with you. So nitrogen is 14, hydrogen is 1. So can we find out the molality is equal to moles of the solute by ammonia is how much? 14 plus 1 times 3, which is equal to 17. 17 over. How much is the mass of the solvent? 119.15 over 1000. Why over 1000? Because you have to make it into liters, right? So whatever you get, the answer that you get, you have to express in small m. Okay, so this is how you find out the molality when they have not given you the volume, the mass of the solvent directly, but they would have given you some hint to find out the mass of the solvent. Okay, so this was the question. Okay, so this was about molality. I just compared it with molarity so that it's easy to remember. So molality is nothing but number of moles of solute in 1 kg of the solvent. Okay, 1 kg of solvent. Now, because we are talking about molarity and molality, in many competitive exam, you have to know the relationship between molality and molarity. Okay, so that you can save some time because you have to do everything very quickly. So when you know the shortcut method or relationship between them, if molarity is given, you can find out the molality and vice versa. Okay, so you have a relationship between them. This is a small relationship between molarity and molality. Okay, so small m is the molality. Capital M is the molarity times 1000 by 1000 d. D is the density Capital M is the molality solution. Okay, now just share the screen and we will do a question so that it's clear. Okay, now over here the relationship is small m is equal to capital M times 1000 by 1000 small d is the density minus m into mb. Okay, I'll just write down m is the molality, capital M is the molarity, d is the density, and mb is the molar mass of the solute, not solution, but solute. Okay, mb is the molar mass of the solute, not solution. Okay, mb is for solute. Okay, let's do a question from here. This is the relationship. So small m is the molality, equal to molarity times 1000 by 1000 d times molarity times molar mass of the solute. Okay, now I'll keep this relationship here and I'll just write a question over here. Calculate molality of 2 molar barium chloride. Okay, I'll be giving the molar masses, so don't worry. Density is, it will be given in the paper, so don't worry. Grams by cc. Barium is 137. Chlorine is 35.5. Okay. Okay. So you are given molarity. Molarity is, capital M is always molarity. Okay. So you are given molarity. You are given molarity. Molarity is 2m. You need to find small m. Okay. Now the solute is barium chloride. Okay. So you need molarity is given to you, density is given to you. What you need is molar mass of solute, which is equal to barium chloride. Okay. So I have provided the molar masses. So barium is 137 plus chlorine is 35.5. How many chlorine atoms are there? 2 of them. So which comes to 172.5. Okay. So you have all the informations now. You just have to substitute it. Okay. So molarity is 2. Molarity is 2. Okay. Times 1000 over 1000 times D is given to you 1.5 minus molarity again 172.5. Okay, this comes to 2000 over 1500 minus 345, which comes to 1.73. Because you are finding the molality, it is small m. So this is a shortcut method to find molality when molarity is given, or vice versa. Okay, if molality is given, you can find out the molarity, vice versa. So if you know this relation, it is very convenient. You can just save time and just substitute the values and just move on. Okay, so these type of questions are very important. So just practiced one of them. Okay. So Mb is the molar mass of the solute. Okay, molar mass of the solute. Now, So students, till now we studied about the molality. Okay, we compared with molarity, and then also we studied the relationship between molality and molarity. Okay, which is very helpful formula you must remember. Okay, students. The next topic that we have to consider or we have to study is normality. Okay, normality. This is also very important concentration term. Okay. Normality is the number of gram equivalents of the solute by volume of the solution in 1 liter. Here also we talk about solution again. So only in molality we were talking about the solvent. In almost all others we were talking about the solution. Okay. So normality is the number of gram equivalents of the solute in by volume of the solution in liters. Okay. Now it is denoted by capital N. Right. So let's check out. So students, we are talking about normality, which is denoted by capital N. Okay. And as I told you, normality is the number of gram equivalents of solute by solute. Okay. Solute by volume of solution in liters. I'll just write L. Liters. L stands for liters. Okay. And it is represented by capital N. Now, what is this gram equivalence? Now, this is a very important topic because unless you understand what is gram equivalence, you won't be able to solve the questions. Okay. So let's check out. So I'll just use another color for this. Now, for explaining number of gram equivalents, I will just write down the formula for moles. Okay. So that I can compare and it's easy for you to remember. Students, now what is this gram equivalent of solute? Okay. In order to explain this, I want to first consider or write down the formula of finding the number of moles. Okay, so that I can compare the formula and it's easy for you to remember. Okay, how do you find the number of moles? It is mass in grams over molar mass. This is how you find out, right? We have been doing this, we did so many sums based on this, right? Mass over molar mass. Now, number of equivalents or number of gram equivalent is given by, same, compare both the formulas, it will be easy for you to remember. Mass over equivalent mass. Equivalent mass, what it is, just hold on, I will come to it. Just first, now I'm just telling you an easy way to remember the formula. Okay, just as you find out the moles equal to what? Mass over molecular mass or molar mass. Similarly, number of gram equivalent is equal to mass over equivalent mass. Okay, instead of molar mass, we use equivalent mass for number of gram equivalents. Okay, now what is this equivalent mass? Is given by molecular mass over X. This X is called as valency factor. Don't worry, when we do some questions, it will be clear for you. So many times if we practice this, it will be easy for you. First, just concentrate on the formula. Valency factor. I'll tell you how to find out the valency factor. It's easy. Okay. So, students, first we understood what is normality. The formula for normality is number of gram equivalent of a solute by volume of the solution in liters. Now there is a new term, number of gram equivalent. What is this number of gram equivalent? For that, what did I do? I took the help of the formula mole is equal to mass over molar mass. Okay? In order to tell you about number of gram equivalent. So just as mole is equal to mass over molar mass. Similarly, number of gram equivalent is given by mass over equivalent mass. Similar formula, right? Now in this, there is one more unknown thing which is called as equivalent mass. Equivalent mass is nothing but molar mass, you know, molecular mass over valency factor X. Okay, now this valency factor X is nothing but, for example, if we talk about acids, acids is nothing but acids dissociate to give H plus ions. Okay, so valency factor is nothing but they tell you about the H plus ions in solution, or if the acid dissociates, for example. I'll talk about acid and bases also. Okay, so if I talk about acid, if I'm talking about maybe sulfuric acid, okay, sulfuric acid will dissociate to give you H plus ions and sulfate ions. Now, the amount of H plus ions given off by the acid is called as basicity. In case of sulfuric acid, what is X? How many hydrogen ions are there? Here, X is equal to 2. Similarly, if I talk about HCl, HCl dissociates to give you H plus ions and Cl minus ions. In this case, how many H plus ions are there? 1. Since no number is there, that's equal to 1. So what is X factor over here? 1. So basically, X factor tells you about the basicity of the acids. How many moles of H plus ions is given off? That's the basicity of an acid. Similarly, we talk about, so I hope till now it is clear. When you practice, it will be okay. For bases, for example, NaOH. NaOH dissociates to give Na plus and OH minus. How many OH ions are there? 1. Okay, so that is X factor. Okay, so similarly, if I say calcium hydroxide, calcium 2 plus 2 OH minus. How many OH minus ions are there? 2 of them. So X factor for a base for calcium hydroxide is 2. Okay, so valency factor is nothing but the number of H plus or OH minus ions given off. Okay, when they dissociate. Now, let's do a question based on this. So, normality is nothing but number of gram equivalent of the solute by volume of the solution in liters. Okay, and number of gram equivalent is nothing. Just remember mole formula, mass over equivalent mass. That's it. Okay, in moles formula it is mass over molar mass, but in case of number of gram equivalent, it's not moles, number of gram equivalent, so mass over equivalent mass, right? Equivalent mass, how to find out? Molecular mass over the valency factor. There's nothing but the number of moles of H plus or OH minus ions given off. Okay, so as we move on, we will discuss for salts also. Okay, I'll just give a question there. I'll just keep this okay. Now the first question, is 0.98 grams of sulfuric acid, okay, are present in 500 ml of solution. Calculate capital N, that is normality. Okay, capital N is normality. Now, formula is already there, number of gram equivalents by volume. Okay, number of gram equivalents, how to calculate? Mass over equivalent mass. Equivalent mass, how to calculate? So we have to start from down. So equivalent mass. I just told the formula, equivalent mass is equal to molar mass by X factor. Okay, molar mass is hydrogen is 1, sulfur is 32, oxygen is 16, and so it comes to 2 plus 32 plus 16 times 4, that is equal to 98 by, what is the X factor, students? For sulfuric acid, we just did it now. Sulfuric acid dissociates to give 2H plus plus sulfate ions. How many H plus ions are there? 2 of them, right? So the X factor for sulfuric acid is 2, right? So I write here 2. I got my equivalent mass. From equivalent mass, what do I get? Can I get the number of gram equivalents? Yes. So equivalent mass is equal to 49. Okay. From here, I will directly apply it in the formula. Okay. So normality equal to number of gram equivalent. What is the formula? Mass over equivalent mass. Okay. Equivalent mass we have now. This is the equivalent mass, 49, right? So number of gram equivalent is equal to mass over equivalent mass. Mass is given to you 0.98 over equivalent mass is 49 by, what is the volume? 500. Can I keep it as 500 or I have to make it into liters? I have to make it into liters. Divide by 1000. And when you solve this, it comes to 0.04 N. Okay, so this gets cancelled. Okay, so it comes to 0.04 N normal. So this is how you do, students. You have to remember the formula. What is number of, how can you find out gram equivalent? Just remember. Okay, and then you have to complete the question. Hope till now it is clear, right? Till now it's okay. I hope so. Okay. Coming to some terms like, just like we did in the previous question, or we did this in molarity. Few terms like if I say semi-normal, just a semicircle, half. It is denoted by n by 2. Binormal. We did this in molarity too. Binormal is 2n. Then you have centinormal, which is equal to 1 by 100 n. And also we did decinormal, which is equal to 1 by 10 n. Okay, because sometimes instead of telling you the normality, they might give a hint like this, 100 ml of a semi-normal solution, like that. Okay, so that's why just you have to remember these terms. Okay, we will, based on this, we will do a question. Okay, I hope till now it's okay, right? Find the mass of NaOH in 250 ml of a semi-normal solution. Semi-normal. They didn't give the normality directly, they said semi-normal. So semicircle, n by 2, okay, semi-normal, okay. Now normality we know, n by 2, and volume we have 250, okay, but we have to make it into liters. We know the normality, we know the volume, okay, we need the mass, but the numerator is number of gram equivalents, right? So what is number of gram equivalent? Just remember the formula of moles, mass over equivalent mass, right? And what is equivalent mass? What is equivalent mass? Is given by what? Molar mass by X. And sodium hydroxide is a base, an alkali. So sodium hydroxide will dissociate to give Na plus. And how many OH minus ions are there? Only one, no number, that means it's equal to 1. So X is equal to 1. And how much is the molar mass? Sodium is 23, hydrogen is 1, oxygen is 16. So sodium hydroxide 23 plus 16 plus 1, that's equal to 40. So it comes to 40 by 1, which is equal to 40. So this is the equivalent mass. So equivalent mass comes to 40. Right. So can we can do so equivalent mass we got, we can do it directly now. Okay. So I'm just rubbing this part. Equivalent mass is 40. Okay. So equivalent mass is 40. Now, semi-normal is 1 by 2. Okay. Number of gram equivalent, that is mass over equivalent mass. Equivalent mass we found out 40. Okay. Over. What is the volume? 250 over 1000. So 1 by 2 is equal to mass by 40 times 1000 by 250. Now you can find out the mass, right? Mass is equal to 40 times 250 divided by 2 times 1000. Whatever is the value, you can find out. Okay. So instead of telling you the normality directly, they can say as semi-normal or deci-normal, etc. So all those terms you have to remember. Right. I hope it is clear till now. Okay. Moving on further. The next topic is relation between, just as we learned the relationship between molarity and molality. Same way, we need to know the relationship between molarity and normality, okay? Because if we know a formula, derivation is not important, but you need to know the formula. If you know the formula, you can save a lot of time, okay? So you can directly do a lot of sums, okay? Now you have relation between normality and molarity. Okay, capital M is molarity, small m is molality. So there should be no room for any confusion. So I'm just writing it though, but there should be no room for confusion. Molarity. Okay. Now let's write down the formulas of both of them separately. Okay. So normality is equal to, just now we learned number of gram equivalent of solute by volume of solution in liters. Solution in liters. Okay. And molarity is number of moles of solute by volume of solution in liters. So denominators are the same, right? So can we divide both of them? N by M. When we divide, we get N by M equal to, we can cancel the denominators, right? Number of gram. Derivation is not at all important. Suppose in case you forget the you can quickly derive it. It's not a big derivation at all. Okay. So sometimes if you forget, it's easy. Just at the side, just do the derivation and you will get the answer. Okay. Number of gram equivalent of solute by moles of solute. Okay. Now, again, number of gram equivalent is what? Mass over equivalent mass. Mass over, just as you find the number of moles. We will be writing that also. Equivalent mass divided by, how to find out the number of moles? When we just did it now again. Mass over molar mass. Right? So here, does something cancel over here? It does cancel. Mass and mass gets cancelled, right? So I'll just rub off this part because this is just, I've written down the formula of, okay. So N by M, I'm left with what? Molar mass or molecular mass by equivalent mass. Right? Because molar mass is going to the numerator side. Now, again, we'll simplify this a bit. Molar mass by, what is equivalent mass? It's just revision of what we did. Is molar mass by X. What is X? Valency factor. So N by M, again, things get cancelled and I get X. So N is equal to mx, where X is the valency factor. This is the relation between normality and molarity. N is equal to mx. Suppose if you get stuck or have a little confusion in the formula, just derive it at the side quickly and you can just finish it off. Okay. But the best thing is just memorize it so that you save a lot of time. Okay. Save the time. Okay. So this was about the relationship between them. Normality and molarity. Okay, so just a basic question we will just do based on this. So N is equal to mx. Okay. So N is equal to mx. X is the valency factor. So the question is, find normality of 0.4 molar H3PO4 solution. Students, regarding the dissociation and all, you don't have to worry because as you move on in grade 12 and grade 11 and grade 12, you will be learning many compounds, their dissociations, etc. So you need not worry. And in the question also, they will provide just hints whether it is completely dissociated or not, etc. Okay, so you don't need not worry about it. So just so we are just concentrating on formulas now. Okay, so H3PO4 will dissociate to give 3 H plus ions. It's also an acid, phosphoric acid. Okay, so how many X factor is how much? 3. So N is equal to mx. So 0.4 times 3, which is equal to 1.2 N. So students, see, if this type of a direct question is given, you need not waste time thinking about the relation, what is the relationship between normality and molarity. Just memorize it, just do it. Okay, so this is how you do the relationship questions. Okay, now coming to the next topic about normality. Yes, here normality of mixtures. Okay, so normality of mixtures. Okay. Here, suppose I am mixing acid and acid. Okay. Or base and base. Acid and acid or base and base. Anyway. Okay, I'm mixing two acids or mixing two bases. Okay. So suppose I'm mixing two acids together or base. Let's take, we are talking about acids now. Okay. So this is acid whose normality is N1 and volume is V1. I'm mixing with another acid whose normality is N2 and volume is V2. Okay. So obviously, when you mix both of them, the volume will definitely increase, right? So I'm getting a mixture whose volume is V1 plus V2 and whose normality is N, right? So how to find the normality N of the mixture? We find out the same similar type we have done in molarity also, okay? N is given by N1 V1 plus N2 V2 by V1 plus V2. This is how you find out the normality of mixtures. Okay, for two acids, mixture of two acids or mixture of two bases. Okay, so here, if a mixture of acids or mixture of bases is given and you are asked to find out the normality, you will use this formula. Okay, N1 V1 plus N2 V2 by V1 plus V2, where N1 and N2 are the normalities of the two acids. Okay, this we can apply to the bases as well. Right. Example, let's do a question. 0.2 normal 200 ml HCl is mixed with 0.3 N 300 ml HCl. Find the normality of mixture. See students, it is mixing up of two acids. Similarly, if two bases are mixed, we can use the formula that we just did. Okay, so N is equal to what? N1 is 0.2 times 200 plus N2 is what? 0.3 times 300 over 200 plus 300. Okay, whatever formula, whatever answer you get, it is expressed in N. This is how you find out the normality of a mixture when two acids are mixed together or two bases are mixed together. Okay, remember this is only two acids mixing or two bases mixing together. Okay, now here we will take a case. This is very important when an acid is mixed with a base. Okay, when an acid is mixed with a base. Till now we were doing when an acid is mixed with an acid or a base is mixed with a base. Now what we are going to do is, which is very important, acid plus base mixture. When HCl is added to NaOH or sulfuric acid is added to NaOH, etc. Okay, acid and base mixture. Now here, I'm taking an acid having normality Na. For easy purpose, I'll just refer to as Na. That means normality of an acid. Okay, and volume of acid is Va. A refers to acid. Okay, and I'm mixing this with a base whose normality is B and the volume is B. For understanding purpose, normality NB, volume is VB for base. When I mix them, this is the acid, this is the base. I get a mixture with a normality N and a volume. You have mixed both of them, so volume has to add up. So volume VA plus VB. Okay. Now In this case, before considering the normality of the mixture, you need to consider when you mix them whether the solution is acidic or basic. Okay, according to that, we have to use the formula. Okay, so you have to check if NaVA is nothing but number of gram equivalents, right? Normality is what? Number of gram equivalents over volume. So gram equivalent is what? NV, right? So you have to check if the NaVA, that is the number of gram equivalents of acid, if it is greater than gram equivalents of a base. NV is nothing but gram equivalents. Okay, so if if the gram equivalence of acid is greater than the gram equivalent of base, that means the solution is acidic. And if it is acidic, that means it will have more of H plus ions. And that time you will use the formula normality, because there are more of H plus ions, right? You will use the formula NaVA minus NbVbY, because gram equivalence of acid is more, divided by Va plus Vb. In case the other way around, if I have, so this I am saying, if I have, I'm using another color, the gram equivalent of base, if it is more than that of acid, what kind of solution? If the other way around, the solution is basic. That means it will have more of what kind of ions? OH minus ions. It is basic. So in that case, how to write the formula? I think you will be able to write it yourself. See, NOH minus ions. When do you use this formula? When you find out that the gram equivalent is more of base is more than that of the acid. When we do the sum, we will better understand. Okay, NbVb minus NaVA. Why? Because NbVb is greater. That means gram equivalent of base is greater than that of acid. Va plus Vb. This is the formula for what? This is the formula for normality of when the number of gram equivalent of the base is more than that of the acid. Okay, so students, these few formulas you have to remember. So when an acid is mixed with a base, you need to check gram equivalent of acid is more or less. If it is more, that means the solution is acidic. It will have more of H plus ions, and you will use this formula, NH plus. Okay, normality of H plus. And if it turns out that gram equivalent of base is more, then you will use NOH. Okay, NOH. Students, there's a small mistake. Normality of OH minus ions is NbVb minus NaVA by Va plus Vb. Okay. So just by mistake, I wrote Vb there. Okay. So I'll just rewrite the formula of normality of OH. So normality of OH ions, that means normality when the solution is basic. Okay. That means NbVb minus NaVA. That means number of gram equivalent of base is more. Va plus Vb. Okay. So students, these are the two cases that you have to understand, okay, before using the formula when you mix an acid with a base, okay. So when the solution is acidic, you will use NH plus this formula. Gram equivalence of acid is greater than that of base. So NaVA minus NbVb by Va plus Vb. Okay, if the other way around, if the gram equivalent of base is more, then you will use the second formula, NOH is equal to NOH is equal to NbVb minus NaVA by Va plus Vb, where NV is nothing but gram equivalents. Okay, so let's do a question based on this. It will be more clear to you. Okay, so I'll just write the formulas here and keep it so that it's easy for you to remember. Okay, so N is equal to NH plus NH plus is equal to NaVa minus NbVb by Va plus Vb. Okay, so this is a formula. And if it is for base, the other way around. Okay. Okay. Coming to a question over here. This is one of the JEE questions. Okay. 0.2 normal 100 ml HCl is mixed with 0.3 normal. Maybe the numbers are different. Maybe 200 ml NaOH. Okay, so acid is reacting with a base, right? Now over here, acid is HCl and base is NaOH. Okay, now over here, what is our first step? First step is checking. Check what the gram equivalent is, acid is more or the base is more. What is the formula for gram equivalent? NB. Okay, so let's check. NaVa is for acid, A is for acid, right? N is, capital N is 0.2 times 100, which is equal to 20. And for NbVb, it is what? 0.3 times 200, which is equal to 60. Right. So where is the gram equivalent more? So clearly NbVb, gram equivalent of base, is more than that of NaVa. So here you must be asking that 2N normal HCl, it's the normality of HCl. Yes, it is the normality of HCl, but HCl dissociates to give H plus ions. Acids are nothing but the amount of H plus ions in solution. So it's indirectly refers to the normality of H plus ions as well. Okay, so when you have gram equivalents of base more than that of acid, base is more than that of acid, so that means the solution is what? Basic. The solution is basic. So now how to find out the, if it is basic, how do you find out the normality of OH minus ions? You already know how to find out. So here, the same formula here, that normality of OH minus ions is equal to NbVb minus NaVa by Va plus Vb. Do we have all these information with us? We do have. I'm just rubbing off the question over here. I'll do this with another color. NbVb is how much? 60 minus, what is NaVa? 20 by, how much is the volumes? 100 plus 200. 40 by 300. Whatever answer you get, N is the unit. Okay. So students, this is how you find out the normality when an acid is mixed with a base. Okay. Previously we did acid with acid, base with base. Okay. So students, these are some of the concentration terms we discussed. Okay. And in the coming video, we will be doing some past paper questions from JEE and NEET based on all the formulas that we discussed, or maybe if required, small shortcut formulas will be given as we practice the questions. Okay, students, that's all for today. Thank you. Have a nice day.